Today's lab is the Chemical Alchemy Lab, also called the Penny Lab. In this lab you're going to be working with some materials as far as chemically, one of which is sodium hydroxide. It's a 2 molar solution. It's fairly dilute, however. Got to be careful of sodium hydroxide because it's commonly found in drain cleaners. As far as the other materials, you can see that we're going to be using some beaker tongs and glass stirring rod and forceps, some other materials that you'll see in here. You also want a clean, shiny penny that's minted after 1982. Some tap water, and there's also some other stuff that you should be having in here, but I don't see it mentioned. Huh. That's for me to put that in there in the future. As far as the procedure, what we want to first do is clean a mass of copper penny and record the mass in our data table. If your cleaning is necessary, use a small piece of steel wool to shine the penny before massing. Alright, that's exactly what I'm going to do. I start off with a dirty penny. As you can see right here, it's pretty filthy. It's a 1997 penny, so it has a few years on it. It's got a lot of dirt and crud and a lot of oxidized materials on the surface of the copper penny, so we want to clean it up so it's all nice and shiny. So that's what I'm going to do right now. If I just place a little bit of pressure here, I can clean this penny up all nice and pretty so it's basically as good as new. The reason why I'm doing this is when I do this reaction, I want to make sure the chemicals can adhere to the surface of the penny. What we were first going to start doing is attach some zinc, a very thin coating of zinc to the penny, and then eventually let it cook with the copper atoms that are on the surface of the the surface of the penny. When those two materials combine, we'll make an alloy. It'll change colors. So I'm going to continue doing this, and you're going to stop watching me. Probably my fingers anyways. Now that I've cleaned my penny, I'm going to go and mass it on the scale. So I'm just going to take it, pick it up, stick it right on the scale here, just like that. And I'm going to see that it has a mass of about 2.49 grams. Now, so that's my initial mass of a copper penny that I want to record in my data table. This is sodium hydroxide. Looks kind of like water again, which many of these chemicals that we work with very much look like water. However, this stuff is nasty to the skin, so you got to be careful. If you ever get it on you, wash it off promptly. So what we need to do is measure out 25 milliliters of solution. So that's what I'm going to do right here. Measure out 25 mils. So I go like so, pouring. Lovely. Alright, now we want to transfer that over to our 150 milliliter or 100 milliliter beaker. Here's my 150 milliliter beaker with my 25 mils of sodium hydroxide. I'm going to just pour it into my beaker like the instructions say to do. Just like so. Doesn't look like much, and it isn't that much compared to the volume of that beaker, and which means it's going to boil at a faster rate, which is good for us, so we're not sitting here waiting forever. Now that we have our sodium hydroxide solution at a boil, we want to add our zinc. But first I'm going to add my penny, which again, very shiny. I want to throw it in there, just drop it in, and that sodium hydroxide is going to kind of do its job with reacting with the copper, soften up the surface a little bit. And I'm going to throw in my powdered zinc. My powdered zinc looks something like that. There's a little chunk of it though. Throw it in and let it cook. We're kind of making penny soup here. What's going to end up happening is the penny is going to get coated in zinc. And so I take my stirring rod, which is probably in my drawer here somewhere. Oh, that looks lovely. Start stirring it up. Stir it up, stir it. We're going to lower the heat a little bit as well. Just stirring. It does not take very long to actually get the zinc to adhere to the sides of the penny. I bet you if I were to look right now, it probably has a good silver color to it, but I'm going to let it sit in there and soak for about another 30 seconds. I also probably want to grab some tweezers or forceps and my crucible tongs right here. Get them ready to go. I could technically take this beaker off if I wanted to. I probably will. So, again, just stirring it up. Probably did it right there. Take my forceps and try to find them. It's hiding in there. I know it is. Ugh. Come on, Penny. Oh, you were right there. Throw it into my cold water to kind of rinse it off. As you can see right here, just throw it in there. It's got a nice silver color to it. It might have a little bit of excess zinc that's on the surface that we're going to wipe off. Just like so. Oh, it's a slippery darn thing. Take it out. Take a very wet paper towel and try not to lose your penny. You might be able to just kind of wipe it off just gently. Oh yeah. That's looking good. So take a look here. We got a very nice silver penny. It's got that nice color to it, and we want to dry it off completely. That's what I'm going to do next. Just dry it off. Alright, taking my silver penny, or at least a zinc coated penny, and massing it out. I want to take it, just pick it up, stick it on the scale, just like so. And we record our mass in the data table as well, seeing it's 2.49 grams. Doesn't seem like it changed all that much. And taking a look, it looks like it's changed. It's silvery colored, so thinking it might have changed. But maybe just the outside has actually changed, and maybe the inside's pretty much the same. As you can see, very silvery. And now we're going to move on to the next part. So if you're trying to follow along the procedure, step number 11 is where we're at. We're going to turn the hot plate back on to high heat and place our silver penny directly on its surface. Now you might not be able to see this color change very well in the video, but I will have it zoomed in as much as I can so you can actually see something here. But like it says in the procedure, after about a minute or so, that silver penny will turn to a golden color. So we're going to see a definite color change. And then we'll let it cool off, and then you'll definitely see it probably after I cool it off with the water. But I'm going to take my penny here. Got a hot plate. It's set to low right now, but we can fix that. I'm just going to set it down gently and just let it cook. Now again, this hot plate's hot, so I don't want to necessarily have it sitting there too close to the hot plate because I might do damage to the camera. But if we look here, we can still see it's fairly silver. Maybe I'll start pressing record. I'm going to pause for a second, and then you can see it later. I'm now starting to see a color change. Rather than being a silvery color, now I'm starting to see a golden color. I don't know if you can actually see that from the video. It might look more like a copper penny to you, but you'll definitely see it in a second once we cool it off in the water. So I'm going to take my golden penny that you could probably barely see in the video, and I'm going to shock it with some cold water to cool it off. Here it goes. Now looking in the beaker, you might see it be more of a goldeny color. Alright, just letting it cool off there really quick and taking it out. I could probably just take it out with my fingers if I wanted to, but I'll be safe. And looking here, you might see that now it's got more of a golden color to it. See that? Nice golden color. So something happened. Let's see if it changed the mass at all after doing all that. So here it goes, moving over the scale. Got to dry it off though first. Being gentle not to rub it too much, just dabbing it to dry it off. Trying to get as much of the water off as possible just so I get the true mass of the penny. See again, scale 0, putting the penny on, 2.49 grams. So whatever we did to this penny did not change it all that much by mass. Alright, so now you have all of the data that you really need. If you look at the rest of the lab, you should be able to complete the questions. Just keep in mind the relationship of density. If you've forgotten, here it is. Density is that relationship of mass and volume. So all the problems that you see right there in that back of that page, you have all the information that you need in order to solve those problems. In the very beginning, it's just asking you to calculate density in the rest of that table, so you need to use that ratio. And then the rest of the questions down below are a little bit more challenging because they actually have you doing some math or some rearrangement of this equation. So you're doing some algebra, so you'll need to solve for mass with the given densities that I gave you for all of the different metals. So you see silver and zinc and copper and gold right there. You use those in your questions down below. So I believe that's all that you need to do. Finish it up on your own, and you should be good to go. All right, thanks.